Does Einstein's general theory belong to the realm of science or science fiction? By Frensis Yu. Einstein theorized in one of his famous thought experiments that light should bend as a result of gravitational force. Using the equation F equals ma from Newton's second law of motion, Einstein demonstrated that gravitational force is proportional to acceleration. Because light entering an accelerating spaceship appears to bend to an observer inside the spaceship, Einstein theorized that gravity exerts a pull on light just as it does on matter. Light, however, is not matter. It is an electromagnetic wave and is not affected by gravity. In the following slides, I will demonstrate that gravitational force does not bend light. Because Einstein's general theory of relativity is rooted in the false assumption that gravity bends light, the theory is itself faulty. In the adjacent figure, Einstein is seen floating inside a spacecraft that is itself floating in outer space. If the spacecraft accelerates upward with sufficient force, F, Einstein will be pulled downward to the floor, with the acceleration acting as gravity would if he were standing on the Earth's surface. If a light beam enters through the window, it too will travel in a downward arc relative to Einstein. As a result, the acceleration appears to be pulling the light beam downward as it travels. Einstein formulated his light-bending hypothesis by imagining the path of a light beam as it entered the window of an accelerating spaceship. If the spaceship were moving close to the speed of light when the light beam entered, the light beam would theoretically travel in an arc relative to the person in the spaceship. Because the acceleration of the spaceship was at the same time generating a force that pulled the person to the floor of the spaceship, thereby enacting a pseudo-gravitational force within the spaceship, Einstein hypothesized that gravity and acceleration possessed the same properties. If so, he deduced, then gravity had the power to bend light. In Figure 2, the person in the spaceship sees a light beam entering the window and bending until it reaches a lower level inside of the spaceship. Einstein hypothesized that gravity works in the same fashion and therefore bends light. Note that v is the velocity of the spacecraft and F is the gravitational force. From Newtonian mechanics to Einstein's relativistic mechanics. According to Newton's second law and his gravitational law, force F can be represented as follows. F equals mg, and F equals capital G, small m, capital M divided by r squared, where small m and capital M are the masses of a given particle and planet Earth respectively. G is the gravitational acceleration, capital G is a gravitational constant, and r is the distance. Combining the two equations, we have G equals capital G, capital M, divided by r squared. From this, we can see the profound connection between mass and gravity. Einstein based his theory of relativity on the assumption that light is made up of particles that possess wave-like properties. Since light is a transversal electromagnetic wave, however, it has no mass and therefore cannot interact with gravity. Einstein treated time as an independent variable. His hypothesis assumed a timeless t equals 0 empty subspace, even though the principle of temporal exclusivity means that timelessness cannot exist within our temporal, t greater than 0 universe. Einstein's light-bending hypothesis assumes the possibility of timelessness, t equals 0, as depicted in the figure below. A light beam enters the window of an accelerating spaceship from point A. Because of the acceleration, the light beam strikes the opposite side of the cabin at point B, which is lower than point A. Because the spaceship's acceleration has pulled the person to the floor, acting therefore as a pseudo-gravitational force, Einstein theorized that gravity and acceleration were one and the same. In doing so, he posited that gravity pulls or bends light. In figure A, the person in the accelerating spaceship sees a light beam entering the window from point A at time t equals t prime. In figure B, the light beam strikes a lower point on the opposite side of the moving spaceship at a later time, t equals t double prime. Einstein's light-bending hypothesis turns out to be false in a temporal, t greater than 0 subspace. Just as it is outside of the spaceship, time is necessarily a dependent variable inside of the spaceship. In fact, everything existing inside the spaceship continues to exist within our temporal, t greater than 0 universe. Everything, whether inside or outside of the spaceship, therefore changes with time. In our temporal universe, a light beam entering the spaceship at point A should end up striking the opposite wall at point B, rather than point B prime, with the time for the light beam to travel from point A to point B being delta t. According to Einstein's hypothesis, however, the light beam would strike the opposite wall at point B prime and take time delta t prime to reach there, an amount which turns out to be greater than delta t. Since the speed of light is constant, Einstein's scenario is an impossibility. In our temporal universe, time ticks at the same rate everywhere, including both inside and outside of the spaceship. If the distance from A to B prime is longer than from A to B, it means that according to Einstein's hypothesis, either light must travel faster than its given constant, c, once it enters the spaceship, or time must slow down. Since light is independent of gravity in our temporal, t greater than 0 universe, the path of the light beam should not change once it enters the spaceship. The light beam striking point B prime is actually due to the upward motion of the spaceship rather than any purported effect of gravity. The misguided conflation of acceleration with gravitational force has resulted in scientists generating fictional scenarios, or in other words, theories that should be relegated to the realm of science fiction. Stephen Hawking's theories on black holes and wormholes are but two examples of science fiction being paraded as science. This figure shows a time-composited diagram of Einstein's hypothesis. The light beam, i.e. photon, moves across the spaceship at the speed of light and is unaffected by gravitational forces. The path of the light beam consequently does not change even though it appears to travel in an arc relative to someone inside the moving spaceship. Each red line represents the path the light beam has traveled relative to a fixed point outside the spaceship after time delta t n has elapsed. The endpoint of each line represents where inside of the spaceship the light beam will end up after time delta t n has elapsed. Where v is the velocity of the spaceship, delta t1 is less than delta t2, which is less than delta t3, which is less than delta t4, and so on, each of which is a section of time, and f is the gravitational force. In each figure below, a spaceship is traveling close enough to the surface of the Earth to be subject to its gravitational pull. Figure A depicts a spaceship traveling perpendicular to the path of a light beam as it enters the window. Figure B depicts a light beam emitted by an LED which is attached to the window of the spaceship. Since both spaceships are traveling in different directions with respect to the direction of the Earth's gravitational pull, gravity should affect each light beam in a different manner. Note that in both figures, v is the velocity of the spaceship traveling close to the speed of light, c, and F is the gravitational force acting on the spaceship. Although both spaceships are traveling obliquely to the force of gravity, both light beams remain unaffected by the force of gravity, even if acceleration creates the illusion that they are affected by it. Thus, whether the light beam emerges from outside of the spaceship or inside of it, its path remains independent of the force of gravity. Once again, if Einstein had used a temporal t greater than 0 subspace when formulating his general theory, he might not have come to the erroneous conclusion that gravitational force can cause light to curve and bend as it travels through space. In this slide, we see two spaceships orbiting Earth while traveling in different directions. Both spaceships are close enough to Earth to be subject to its gravitational pull. At time t equals t1, a light beam enters the window of the spaceship on the left, while another light beam emerges from an LED inside the spaceship on the right. At the exact same moment, a light beam radiates from a distant star. In this slide, we can see that a light beam from a distant star travels a radial distance r equals c delta t, where delta t equals t2 minus t1, representing the time elapsed. At the same time, the light beam entering the spaceship on the left and the light beam emerging from the LED inside the spaceship on the right end up traveling the same distance, d equals c delta t. Neither the light beam entering the spaceship on the left nor the one emerging from inside the spaceship on the right is affected by Earth's gravitational pull. This figure shows a time-composited diagram of the particle gravity dynamic, whereby the particle exhibits a mass. The photon exhibits no mass. Vx is the velocity of the particle traveling in direction x. Vf is the average velocity due to gravitational acceleration g at time t2 equals delta t4, and b double prime is the location of the particle at time t equals t2. Einstein's light-bending theory is faulty for the following reason. It is rooted in Newton's second law, and specifically the equation mg equals capital G m capital M divided by r squared, where acceleration g can be written as g equals capital G capital M divided by r. The theory treats light as if it has mass. Light, however, is a wave and therefore exhibits no mass. Assuming the velocity for an emitted particle is equal to or slightly less than the speed of light, Vx equal to or less than c, since every physical particle has a mass m, and mass is necessarily affected by gravity, the path of the particle will be different from that of the light beam. Thus, gravity bends the path of the particle, but not that of the light beam. Concluding remarks. When a great scientist comes up with a new theory, we have a tendency to blindly believe in it. Einstein's genius is one of the reasons physicists have become apostles to the religion of time travel and light bending. There is no physical evidence for time travel and light bending. Scientific theories should be backed up by physical evidence. We have forgotten that the pursuit of science is itself the act of approximating nature's laws, not dictating them. We have forgotten, in other words, that science is never exact. The light-gravity dynamic is core to Einstein's general theory of relativity. Yet, it does not hold up to physical reality. Unfortunately, many of today's scientific theories are rooted in Einstein's general theory. For example, Hawking's theories on black holes and Thorne's theory on wormhole travel. As a result, such theories should be seen as being more in the realm of science fiction than in that of science. Finally, I would like to introduce you to my new book. Some of the thoughts I've talked about in this presentation can be found in this book. Thank you.